So then we have these different types of radiation. I went ahead and put them in a chart because it keeps it easy for my brain, but you don't have to. Alpha is our like least scary type of radiation. Um, it forms a helium atom when it decays. So the thing that's like coming out, basically, you've got this element, and then you've got, it decaying into two different things. It'll turn into helium and something else. This isn't oxygen. This is just a something. Okay. And like I said, this is the least dangerous type of radiation. It doesn't penetrate very far. You can block alpha radiation with a piece of paper. So it's not really going to hurt you. Beta radiation is it's like medium dangerous, I guess. And what I saw in your test and what I saw in your notes is that it produces an electron with a -1 charge. But when I used to teach, we also talked about it producing a positron, which is basically an electron, but a positive one. But I didn't see that anywhere in your stuff. So that's why I just kind of typed electron, because I wanted, you guys to focus on that. But I just couldn't not tell you about the positron, because then I felt like I wasn't giving you the full picture. And then beta radiation, you can actually block that with like aluminum foil. So again, not too bad. Gamma radiation, this is actually an electromagnetic wave, right? We learned about it in our electromagnetic wave unit. So it doesn't have a charge at all, but it can penetrate very, very far, like through your skin, into your cells. Gamma radiation can actually cause cancer. They also use it to treat cancer because it destroys cells. And so, if they can focus it at the cancer cells, then hopefully they'll kill the cancer cells quicker than they kill you. That's basically what radiation is, unfortunately. So these are our different types of nuclear radiation that we can see. Here's like what's going on in alpha. You see it's producing this helium. So with these little formulas, there's a couple things that you need to know. This number right here is the mass number for the element, that top one. Now, I did see on this test that you don't actually have to do any math or any short answer questions on this nuclear test. So that's, good if you're not a short answer person, but not so much if you prefer the short answer to the multiple choice. So all of these top numbers, these are called the mass number. And then this bottom is the atomic number. So like I used to teach my students that sometimes they would have a formula and they wouldn't give you this part. Okay, so you could do, let me see if I can get a 2. You could do 238 minus 234, and you get 4, and that's that top number right there. That's what that was. And then you can do 92, which is the bottom, minus 90, get 2. So you've got 4 over 2, and then you could, go to your periodic table. You could see that that was a helium atom, and then you would know that you've got alpha radiation. I didn't see anywhere where they made you do this math like this, but they did want you to know. They did want you to see these formulas. In fact, this formula, this graphic itself, came from the test. This one did not, but it's the same thing. It's what would happen in beta radiation. This is still your mass number That doesn't change on the top. And this is still your atomic number. But you can see instead of a He at the end, we have an electron. And so it's a mass of 0 basically, because electrons are tiny and they don't really have any mass compared to protons and neutrons and atoms. And then the charge is -1. So because 6 minus 7, right, would be -1. So if you saw this, you didn't have the beta here. You said, oh, -1, an electron. Oh, that must be beta radiation. So they might do something like that. They might give you an equation like this and then ask what type of radiation it is.